Hi, everybody. So I want to follow up yesterday's algebraic properties with some geometric properties. And on this page, you see three properties of congruence. And if you compare them to the algebraic properties, actually, I think I can do that. Take a look at the reflexive property, for instance. It says figure A is congruent to figure A, or an example is segment EF is congruent to segment EF. Let's go back and look at the reflexive property for algebra. Reflexive property, A is equal to A. So something is equal to itself. I'm not going to do that every time because I get a little dizzy going back and forth like that. I didn't notice that far back. But symmetric property, that's the one where you can just flip it around. For example, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. That's just the same property, just flipped around. They mean the same thing. And then here's this tricky transitive property of congruence. If PQ is congruent to RS and segment RS is congruent to segment TU, then PQ is congruent to segment TU. I want to draw your attention here to the colors that they're using. Notice that PQ is in red. It's congruent to something in blue. Something in blue is congruent to something in green. Therefore, the something in red has to be congruent to something in green. Okay, the first one is congruent to the last one. I always give this example. And let's take three football teams. And whether you like sports or not, it doesn't matter. The Seattle Seahawks play in a division that has four very good and pretty equitable football teams as far as talent and how they play. So let's do this. Let's say the 49ers are congruent to the Seahawks. The Seahawks are congruent to the Rams. So shouldn't the 49ers be congruent to the Rams? Or replace it with just as good as. 49ers are just as good as the Seahawks. Seahawks are just as good as the Rams. Therefore, the 49ers have to be just as good as the Rams. So you can compare it to, kind of like two teams being equal or three teams being equal. Transitive property is a tough one. We're going to continue to work at it. I hope this helps a little bit.